And with that, periodically throughout the year, you've heard me use the term inverse operation. Okay? Does anybody remember what inverse operation means? Well, let me tell you this. We could think the inverse of yes is no. Okay? So, if I have addition, what do you think the inverse operation would be? Subtraction. If I have multiplication, what would be the inverse? Okay, what if I have division? What's the inverse of division? Okay, so you need to make sure you understand that vocabulary word. Inverse means opposite. Inverse operation, opposite operation. If it says add, I'm going to subtract. If it says subtract, I'm going to add. Okay, today we're focusing just on adding and subtracting. Tomorrow we'll move on to multiplication and division. Okay? If you look across the top of your book on chapter 15 in lesson 1, in chapter 6 we talked a lot about expressions. Okay? What's significant about an expression? It doesn't have an equal sign. Okay? An expression does not have an equal sign. An equation is our vocabulary word today. An equation is going to have an equal sign. We're going to find an answer for that variable. Okay? They're still giving us something that is unknown. They're still giving us a variable. Now we're going to figure out how to get that answer. Okay? Chapter 6 was all about we need to accept that sometimes we have letters that can represent something that we don't know. Chapter 15 is all about figuring out what that letter is or what number that letter is representing or standing for. Okay? So, by the end of today's lesson, you should be able to make sure that you can solve an algebraic equation using the inverse operation. Sounds complicated, I promise it's not. You're going to look at me and say, Mrs. Wiseman, are you serious? This is all you're teaching me today? And I'm going to say yes. Okay? Okay. Let me show you something. If I have something that looks like this, we all know that's equal to 5, right? Yeah. Okay? What we're going to focus on today is whatever I'm going to do to one side of the equal sign, I have to do it to the other. Okay? In comparison to today, we practice adding and subtracting fractions. Whatever I did to the denominator, JT, I had to do to the numerator. Okay? We're going to look at this today as the same thing. Whatever I do to the left side of the equal sign, I have to do to the right side of the equal sign. Okay? So, think with me if you will. I could rewrite this as and that's still the same thing, right? This side is still equal to this side. There's a dark spot there. Okay? All I did is I added 2 here, and since I added 2 to the left side of my equal sign, I had to add it to the right side of my equal sign. Because order of operation tells me I can take 9 minus 4 and get 5. 5 plus 2 is 7. So this side of the equal sign is equal to 7. This side over here better be equal to 7 also. 5 plus 2? 7. Okay? Just the same as up here, 9 minus 4 is 5, and 5 is 5, right? Yes. Okay? So, what my goal for you to understand is, when I have that expression, my sides have to be equal. Okay? I could add a 6 up here, 6 plus 9. I would have to add a plus 6 over here. Okay? Whatever I do to one, have to do to the other side. Sorry, that went off the page. Okay? So that's part 1 that you have to make sure that you understand. The same thing goes with subtraction. If I have something that looks like 8 plus 6 equals 14, Okay? I could take that and I can put 8 plus 6 minus 3, as long as over here I put the minus 3. Okay? If I'm going to decide I want to subtract 3 over here now, I better subtract 3 over here. Otherwise, they're not equal. I have to balance the sides. They have to be equal. Okay? So 8 plus 6 is 14. Minus 3 is 14 minus 3? 11. I balance the sides. They're equal. Okay? Whatever I do to one side, I have to do to the other. Make sense? Yeah. All right, let's get into the inverse operation. Yes. But that's not really the whole skill I'm teaching you today. We're getting there. Okay? So, now we're going to be presented with something that looks like this. Okay? And a lot of us, if we really thought about this, we could figure it out, right? Yeah. A number minus 45 has to equal 90. In our math, we have kind of learned to do this on a small scale where they might say x plus 2 equals 6. Okay? And you have been taught to mentally think, oh, if I just take 6 minus this, that's going to give me what this is equal to, right? No. Yeah. 6 minus 2. 4 plus 2 is 6, right? Yeah. Okay? Here's the reason behind why that works. Going back to equations, whatever I do to one side, I have to do to the other side. From now on, we're going to try to get this variable that they give us. We want to get it by itself on one side of the equal sign. Our goal when we're solving these equations is to get that variable by itself. Okay? How do I want it to look like, in the end, x equals a number. I want it to be just a number here. I want to get that variable by itself. Okay, so we talked about the inverse operation. If I subtract 2 from this side, now I have x plus 2 minus 2. Well, if I have 2 and then I take 2 away, that gives me 0, right? Yeah. So those two cancel each other out, and I'm left just with x. Since I subtracted 2 here, what do you think I have to do over here? Since I subtracted 2 here, what do you think I have to do here?
Subtract 2.
If I subtract 2 here, I have to subtract 2 here. 6 minus 2 is 4. Then, I'm going to plug 4 in for my variable to make sure that this is true. Is 4 plus 2 6?
Yes.
Okay? Now let's think about this example here with a larger number. Okay? They're telling me when I have something that looks like this, it says minus 45. I'm going to do the inverse operation to get that variable by itself. By inverse, I just mean opposite. So I'm going to write this as x minus 45. And if I want this to be 0, I need to add 45, right? If I have 45 and I take 45 away, that gives me 0, right? Okay, that's what I want. Because a negative 45 plus 45 gives me 0. So now I'm left with just my variable. If I added 45 here, what do I have to do over here? Add 45. 90 plus 45 is 135. If I want to check my work, I'm going to put 135 in for x. 135 minus 45 gives me 90. It better give me 90, otherwise I made a mistake.
So all we have to do is
Hello?
Instead of doing like all that
I'm showing you why it works. As long as you're understanding that you have to do that inverse operation. No, you can't do 90 minus 45 because 90 minus 45 is 45. If I put 45 in for x, 45 minus 45 is not 90. You have to know you have to do the inverse to the other side. Does that make sense? Okay, let's work through another one. Okay, I have x minus 12 equals 37. What's the issue?
He doesn't have one.
I'm excited to see some boards with the right answer. Some of you were staring at me and I felt like I was talking way over your head. Those of you that have your board up, you can put them down. Some of you are just taking minus 12 over here. You can't do that. You have to do the inverse. I'm going to write this as x minus 12. In order to cancel this negative 12 out to get 0, I have to add 12. If I'm adding 12 over here, I have to add 12 here. Okay? If this says subtract 12 here, your brain should start thinking, I need to add 12 over here. I need to do the inverse to the other side. 37 plus 12?
49.
X equals 49. Okay? If they say A plus 8 equals 37, we would read this as something plus 8 equals 37. Okay? If I have an add 8 here, I'm going to do the inverse to the other side. So the inverse of adding is subtracting 8. I'm going to subtract 8 over here. So I'm left with A equals 37 minus 8, or A equals 29. Alright, I'm going to give you 2, and they are your ticket to your homework. Your homework is going to be the odds of the workbook page. Okay, if there is not a subtraction sign in front of it, it's automatically considered an addition sign. Does anybody know the workbook page?
No.
15-1, can you tell me, Braylon? You're doing the odds on 107. Go, Derek. Go, Hannah. Go, Paul. Go, Jeffrey.